So to give you a reference, GPS has 500 of these IGS stations, which is used to correct their satellites in space. Because as you can understand, so as a user on ground, you are receiving PNT signals from the satellites. But who is telling the satellite where exactly they are, right? So for satellites, like they also need to know its location to then provide the user its accurate positioning. This is how GNSS work. But there is nothing in space to tell them where exactly they are, right? So we have built an entire ground station infrastructure to tell the satellites that you are at this particular location. Now this is where we are coming up and doing everything on board the satellites, so that the satellite itself will know its location in space, and we will have very less dependency on ground stations on ground.
Hello and welcome to another episode of Specially Focus, where we explore the frontiers of India's deep tech ecosystem. Brought to you by Specially Invest, a leading early stage deep tech VC firm in India. I'm Hari, and in this episode, we sit down with Lokesh Kabdal, Vibhor Jain, and Anurag Patil, founders of Aerodome Technologies, better known as VyomIC, for the eponymous satellite constellation and positioning, navigation, and timing (PNT) platform they're developing. VyomIC's journey started from the elite IIT Madras ecosystem and the Avishkar Hyperloop project, in which these entrepreneurs were part of the core team while at the institute. Their path took a pivotal turn during a drone show where signal jammers used for security purposes exposed some of the dangerous vulnerabilities and precision gaps of current GNSS or Global Navigation Satellite System infrastructure. This realization led to the creation of VyomIC, an Indian satellite constellation being designed and developed to secure the nation's place in the global low Earth orbit PNT race. Lokesh, Vibhor, and Anurag expect that VyomIC will be able to offer signals that are at least a few orders of magnitude stronger than those from the geostationary satellites of the existing GNSS systems. They also expect to offer centimeter-level precision even inside multi-story buildings. As PNT becomes the backbone of all critical infrastructure, from defense to telecommunications, these founders are setting out to overhaul and overcome the limitations of legacy PNT technologies. Join us as we discuss their mission to build a sovereign, unbreakable infrastructure for PNT and why they believe India must prioritize innovation over frugality to lead the next generation of space technology. Okay, so Lokesh, Anurag, Vibhor, thank you all for making time for this. Welcome to Specially Focus. Really looking forward to this conversation with you guys, and you all are developing some technologies in a very important strategic area for India. So I'm quite excited to learn more about it and bring it to the audience of Specially Focus. So let's start with a simple backgrounder. Tell us a bit about how the three of you came together. How did you start the company? And I can probably say briefly for to our audience that there is a Hyperloop connection. I know you all have spoken about this many times before, but for folks who have not, who don't know about you, might be interesting for you to just talk about that for a minute, and let's go from there. All yours.
Yeah, thank you so much, Hari, for having us in this podcast. So I'll give you the history of VyomIC, and before that, Aerodome Technologies, and before that, we were grads in IIT Madras. Right. So the journey started when we all three were part of Avishkar Hyperloop while being in IIT Madras. We all studying different. So I did my masters in IIT Madras with machine design. Same for Anurag, and Vibhu did his graduation from IIT Madras in civil engineering. So this is how we all connected through Avishkar Hyperloop. And we spent 2 years. We were leading the team. Hyperloop is essentially a maglev train inside a vacuum chamber. This is a very easy way to understand what it's a fifth mode of transportation, which is evolving quite a bit as of now. And so we built this entire 420 meters long Hyperloop track tube as well as the ecosystem, which is now operational. It is inaugurated by Cabinet Minister Shri Ashwini Vaishnav sir. And yeah, right now a company which is a spin-off from Avishkar Hyperloop is taking it forward in the commercial stages. So we were the first team, I think, in Asia to develop Hyperloop facility of this scale. And while we were developing this, we thought that we understood product development, and we raised around 10 CR while working in this Avishkar Hyperloop. So 8.3 CR came from the Indian Railways, and the rest is from CSR from different corporate industries. Uh, yeah, so while we were doing this, we understood that we know a bit of product development. And if you guys want to add something, yeah, Vibhor and Anurag.
So Vibhor was the like infrastructure head, and me and Lokesh were the team leads. And then so this like we were part of this team for 2 years, and then when we graduated from IIT Madras, we thought of starting wanted to do something of our own, like something in the tech domain. And that was the time when drones was getting highlighted a lot by the Indian government. So at that time, government had put a ban on import of the Chinese drones, and there was a lot of demand from the defense side as well. And the swarm drones was a new concept. Like there were very few companies that were working on the swarm drone and drone tech. And then we started the Aerodome Technologies, the venture, which was main focus was developing swarm drones for various applications. And the first application that we pick up was drone light shows. So entire like when we started, we didn't know anything about the drone. So as Lokesh mentioned, like we knew the product development, so it was easy for us to start the development from the scratch. And in 1.5 years we developed 60 drones. We did all the prototyping of the drone, built all the hardware right from the scratch. And in so we started in 2023 June, and in 2024 December we did our first drone light show for the Gujarat government. That was a chief minister's event, and that was our first show. And later, like we did couple of shows, 4 to 5 shows in commercial as well as all the commercial shows, but in public as well as private events. And during the development, like we came across a bigger problem, that is GNSS infrastructure. The way GNSS works today, the way the positioning happens today, is that has quite lot of gaps, and that has like way lot of innovations that can be done to improve the existing system.
So that's how basically how we realized that the GNSS has two major problems. First is it's not precise enough. To get precision for operations like drones, autonomous vehicle, precision agriculture, you need centimeter level accuracy, which is not really available with the existing infrastructure, which is GPS, GLONASS, Galileo. The second problem was very interesting when we were doing the first show for Chief Minister of Gujarat. Because of the jammers present in his security, our drone's communication link got jammed, through which we sent communication of the correction messages to correct the GPS. So that's how these were the two major problem statements: the jamming and spoofing, as well as the precision problem, which got us to think how we can solve this problem at a large scale. In January 2025, we started thinking or exploring what are the different options, how we can solve this problem. And that's how VyomIC was born, which is basically the branding of what we are trying to do now, which is building a constellation of low Earth orbit satellites for very precise and secure position, navigation, and timing services. So yeah.
So if you see that the name itself, VyomIC, right? It came from a vision to have a large constellation in space, which will serve India as a main focus, and then global for various applications. So Vyom in Sanskrit means space, and IC stands for Indian constellation. So it's a space Indian constellation which we are trying to come up with, primarily focusing PNT in start.
So the company was started in 2023, right?
Right.
So now you're focusing on the PNT aspect of this. And again, for a general audience, GNSS stands for Global Navigation Satellite
Satellite
System. Is that
system.
correct?
Right.
Yes.
So I'll give you a brief of GNSS to start with. So GNSS is Global Navigation Satellite System. So all the systems which works in global navigation comes under this GNSS umbrella term. A PNT is a service. PNT is Positioning, Navigation, and Timing Services. So let's say every equipment which it turns on asks three simple questions. First is where I am, which is position. Second is where I'm heading, which is navigation. And third is what time it is, which is timing. So PNT is a service which we avail from these GNSS satellite systems. GNSS has four major constellation, global constellation, which is GPS, which we all know from USA, then GLONASS from Russia, Galileo from ESA, European Space Agency, and then Beidou from China. These are the four global constellation in satellite navigation. Then we have two regional constellation, which is also called RNSS, Regional Navigation Satellite System. We have NAVIC, which is built by India, and then we have QZSS, Quasi Zenith Satellite System, which is built by Japan. So these are the two regional and then four global navigation satellite system. All these provide PNT signals to the user.
All right. So the PNT work has now you've been working on it for the last 2.5 years or so.
Right. So, because in drones also we developed this RTK system, which is real-time kinematic positioning, which is a part of navigation. So while we were working in the drone segment, we were also working in the navigation because we configure our own RTK system. We build our own RTK system as well for the drone system. So we can say we have a heritage of navigation for the past 2.5 years. Dedicatedly, we have been working in this LEO PNT for past 1 year.
Okay. So let's talk about the problem that you first identified, during the show in Gujarat, where you found jamming to be an issue. Can you delve into this a little bit more in the sense that denial of this kind of signals and timing and so on is a sort of a global issue now? Give us a layperson's understanding of both the global context for this problem as well as what India has been trying to develop, and then we can talk about where VyomIC fits into that.
Right, right. So I think there are three major problems which we're trying to focus on. First is precision, second is security, and third is availability. So talking first about precision. So if you see, I think in very simple terms, I think every one of us uses Ola, Uber, or any of these ride hailing services. So while you book the cab, you can see your location on the map, right? And you might, like every one of us might find some other time that the location on the map is a little bit different from the actual location where you're standing at. Like it might be in 3 to 5 meters of vicinity. So that's exactly the precision problem or inaccuracy in the positioning which comes from GPS or any of the GNSS constellation. So this is all right for humans to work on, but when systems become autonomous, let's say drones, drone deliveries, drone surveillance, autonomous vehicle, precision agriculture, construction autonomy, all of these things require very precise centimeter level positioning to operate. So that is the first problem which we're trying to cater to or solve for. The second is about security. So right now, GNSS systems are very prone to jamming and spoofing. Very recent example of this is Delhi airport GPS or GNSS got being spoofed, because of which the timing system got delayed and everything. Many of the flights got delayed. So previously, it was thought that all of these actions like jamming and spoofing would be border areas or war-like situation scenarios. But right now, all of these things are penetrating deep inside civilian areas as well. So it is happening across Europe, across USA, India, everywhere, basically, because it's very easy to jam GPS or GNSS signals. You just buy like $120 software defined radio. You get open source code available to jam GPS. You can jam the GPS with that low powered uh, laptop plugged in system to like 5-6 kilometers of radius. So that's how easy it is to do. So that is the second problem which we're trying to solve. And the third is about availability, which is basically the signals are not really available everywhere. So in urban areas, urban canyons, forest areas, or basically any confined space, indoor, outdoor, the signals are not really strong to penetrate inside buildings, to penetrate inside forest cover, etc. So it's not really available every time. And specifically for India, because I think how the NAVIC program or Indian regional navigation system program started was because in 1999 we were denied GPS signal during the Kargil war. So that's how we realized the importance of such a fundamental infrastructure like PNT, and that's how we started development. So definitely we would need our own every time available infrastructure for position navigation and timing. So yeah.
So people don't realize how critical the PNT infrastructure is. For them, it's just like when we had this conversation with more people, their understanding of PNT or GNSS is just limited to Google Maps. So Google Maps is not someone who has put the satellites in outer space, right? It's a GPS who will take the signals. Your receiver mobile has a receiver who takes the PNT signals and then convert it into a PVT, position velocity timing estimates, and then Google Maps is an application which takes this information and then put up on the on a certain map. So people don't understand how critical this entire infrastructure is. So, and when we talk about PNT, the major part of it goes to position. Right, the major light was taken by the position, and timing remains under the dark. However, the timing is the one of the most important part of PNT. So let's say your entire telecommunication ecosystem depends on timing synchronization, which comes from GPS or any of these GNSS satellites. Then your entire data centers, financial institutions, all these critical infrastructure, power grid, right? All these are synchronized with GPS timings, GPS or let's say NAVIC times. So this is how critical the timing sector is. This is how critical the precision sector is. And it's not like people have not understood the importance. So people who are working in the industry, they know how critical this system is. As Vibhor mentioned, that we have three of these very important problems to solve: position, security, and the availability. So we have solutions for all these particular systems. Let's say when we take position, there's an entire augmentation ecosystem around position, which is there to augment the existing precision. So existing, let's say precision of the shelf is 3 to 5 meters, but then people have built an entire ecosystem for augmenting this 3 to 5 meters to centimeter level of precision, but that itself is not secure. Now let's come to security. There is Gagan ecosystem which is built by India, right? Gagan is augmenting GPS for integrity. Now we have invested 80 to 90 million dollars in building up this system. Just provide integrity on your position estimates. So if your receiver is giving you an answer, that answer should be correct. And for this, like, there is an entire ecosystem which will take care of this integrity. Every continent and every country, major country, will have their own augmentation system. So US has VAS, India has Gagan. All this system will provide you integrity. So that's the solution, alternate solution for your security. Now coming to your availability. So Japan has this QZSS constellation, regional constellation, which is there to tackle the problem of urban canyons. So Japan, as we all know, like have a lot of buildings in Japan. So it's very difficult for them to get the direct line of sight from this GNSS signals, and they have a lot of tunnels and all those things. So the availability of GPS signals is not very good in Japan. So they built an entire satellite system to take care of this problem statement. Even now, there is no availability of PNT signals in indoor. So when you sit in your office, when you move around the big warehouse and all, you don't get PNT signals.
So, the work being done by VyomIC, would it be complementary to NAVIC, or can it be a full-fledged alternative? As of now, how are you looking at it?
Yeah. So the development that we are looking of as of now is, of course, it will be a complementary to the NAVIC, but we are also building a capability that even if there are areas where NAVIC doesn't work, like as in like NAVIC is a regional constellation, and we are building for the globe. So there are areas where the NAVIC signals won't be reaching, but the VyomIC's signals will be present, and they will be able to do full-fledged positioning, navigation, and timing systems as well. And as far as like Navic's plan is concerned, they have planned to complete their regional constellation and then move to global constellation. But yeah, in the coming years, and yeah, as you mentioned, like there were certain failures in the Navic. That was basically because India, like in last 20-25 years, has been working on the navigation, but the main part that is required in the entire navigation satellite is the atomic clocks. And India didn't have its own atomic clock. It had imported those clocks from US and from Russia as well. And there were failures in those clocks. Because of that, the satellites were not able to perform. But now, moving like in last 10 years, India has made its own atomic clock, and they have been tested in the recent satellites, and they have planned to replace all those clocks with the Indian made indigenous clocks. And yeah.
Right. So I think whenever we ask this question about Navic and VyomIC, we say it's not VyomIC or Navic, it's VyomIC and Navic. So it's a complementary system, because at the end, if you see all the space sector, so space sector is very different from the other sectors, right? Space sector does not work on individual industry. So whenever you say Vyomic, it's not a company. We are representing India as a nation, right? So it's let's say the global Leo PNT race. Now it's not the race between the industries. It's not AMD is coming up with their chips and then Intel is coming up with their chips. It does not work like this. In this, the nation come up with their own architecture. So when we say, if our competitors, Zona Space System in US, Trustpoint GPS in US, right? So we always say the US Leo PNT space. Then in India, Vyomic is coming up with their own Leo PNT architecture. So we are representing India as a nation in this Leo PNT race. It's a space war which we are entering now in this era. So we have US in Leo PNT, we have India in Leo PNT, China in Leo PNT, then Japan is working on Leo PNT constellation. ESA is working very hard on the Leo PNT satellite constellation. So we as a nation, we look this not as an industry, but also as a nation.
Okay. Um, so let's talk about what it is that you're actually developing. Can you give us a simple understanding of the technology that you have developed so far and also the eventual commercial product?
Right. So in short, we are building global satellite constellation for navigation. So eventually, we are building satellites, small satellites, which will then provide these PNT signals, which till now we were receiving from these bulkier satellites, which is out there in space, 20,000, 36,000 kilometers. So I'll first divide the space in three different orbits from the navigation perspective. So we have geo orbit, in which regional constellations are there. So let's say NAVIC and QZSS operates from geo orbit. Then we have MEO orbits. Now geo is 36,000 kilometers from Earth's surface. MEO is 20,000 kilometers from Earth's surface. Now MEO is the orbit where all these four major constellations which we discussed previously, GPS, GLONASS, Galileo, and Beidou, is there. Now, coming from these distances, the signal becomes very weak when it reaches to the Earth's surface. That's why, like, the jamming and spoofing becomes very easy, and we don't get precision out of the shelf. We are building these satellites for LEO, which is less than 2,000 kilometers. So the signal inherently will be improved from these satellites. Now, the some of the major subcomponents of these satellites, as Anurag mentioned previously, is atomic clock. So we are coming up with our own atomic clock architecture, which will not be the conventional atomic clock, but an ensemble of uh, available products which is there out in the market. So basically an atomic clock architecture which we are building for our own satellites, and there will be other set of, let's say, navigation signal generation unit. Then we have orbit determination module. So all these subcomponents will then be act as a payload subsystem, and then will provide high signal strength PNT signals from it. So let's say, to give you a perspective, our signal will be 100 times to 1,000 times much more stronger than the existing ones. This is one part of the technology. Our signals will be much more precise. So we are talking about centimeter level of precision here. Our signals can penetrate, let's say, 10 stories building as well. So you will get PNT signals inside your office, inside your warehouses, inside your factories. And there is much more advancement when you work on a Leo PNT system. Coming to the commercial product, I think, Vibhor, if you can take this part.
Yeah. So I think one of the major, or I would say like the major thing which we are going to commercialize is the signals. So the USP of our signals is first, it's going to give very precise positioning and timing information. Second, it's not spoofable. So it's completely spoof proof with our encryption authentication methods. Third, it's going to be jamming resistant. So when we say jamming, it cannot avoid completely jamming, but it will make jamming very, very difficult because the signal strength is very high. And the fourth point is where the signals which we provide would be able to penetrate buildings. Indoor PNT is possible, indoor timing for telecom data centers, power grids, all of these things is possible with our signals, with security introduced. So this is what the commercial product or commercial side would look like, where we would like to give our signals with subscription or at a licensing fees or something around that. Yeah.
So today, where are you at? What have you already done so far, and what comes next?
Right. So currently we are a team of 14 people. Over a period of time, we have gathered so we have divided our team into various subsystems that we are working at. So as Lokesh mentioned, one is precise orbit determination team, one is the timing team, one is signal architecture team, then there is mission design team, and then there is satellite team for integration and manufacturing. And so each of the modules we have picked out, like we have constructed our advisors team as well, who the people who have been working in this domain for like past 10-20 years, who have worked in ISRO or from outside ISRO as well. And so our current plan is like to do a space based demonstration in next 18 months, which will test all the subsystems that we are working on currently, which will provide the precise ranging signals, precise timing signals, and the security part as well, the authentication part as well. So these three are the demonstration that we are targeting next 18 months. And yeah.
So currently we are developing the payload, which is the PNT payload, India's first PNT payload. And if you see, like, the navigation is very complex. When we say satellite navigation, it's the most complex application out of all the existing ones. So let's say if we divide space into three major application. First is Earth observation, where we have couple of companies. Galaxy is one of them. Then we have satellite communication. Satellite communication is nothing but satellites which relay your information from ground stations to then your end user, and satellite act as a relay. Then comes the satellite navigation. Now, satellite navigation is slightly more complex because it's not just the satellites in space. It requires an entire infrastructure. So, if I divide satellite navigation, it will be in three broad segments. First is space segments, where we have to launch all these satellites. Then comes the ground segment, which will be used to correct the satellites in space. Now comes the user segment, which will then take this PNT signals and provide PVT estimations to the user. So it's a very complex ecosystem which is there. And till now, the GPS started in 1970s, and it's been 50 years. The entire ecosystem has not changed even a bit. So we have moved from doing normal calculations to now doing AI, right? But if you see, the navigation has been stuck for the past 50 years. We have not moved, even a single bit. The signal structure is same. The satellite structure is same. The entire ecosystem of the PNT, as in the space segment, the ground segment, the user segment, is same. And this is why, because when GPS started, they worked on certain signal architecture, right? Now, all the receivers, today we have, as we are speaking, we have 7 billion GNSS receivers. All these receivers have been manufactured taking those signals into consideration. Now, it's very hard for the entire ecosystem to move from that particular heritage system to a new system. But now we are seeing the changes in the industry. So we are bringing innovation in all these three segments. Space segment, the satellite would be very small. The satellite is much more powerful. At the same time, we are bringing innovation in the ground segment. So and when you say ground segment, it takes a lot of infrastructure, cost, and manpower to maintain and to build this infrastructure. So our satellite system will be such that we will be having less dependency on the ground ecosystem. So we will not build many. So to give you a reference, GPS has 500 of these IGS stations, which is used to correct their satellites in space. Because as you can understand, so as a user on ground, you're receiving PNT signals from the satellites. But who is telling the satellite where exactly they are? Right? So for satellites, like, they also need to know its location to then provide the user its accurate positioning. This is how GNSS work. But there is nothing in space to tell them where exactly they are. Right? So we have built an entire ground station infrastructure to tell the satellites that you are at this particular location. Now this is where we are coming up and doing everything on board the satellites, so that the satellite itself will know its location in space, and we will have very less dependency on ground stations on ground. At the user level, you are limited by the signal structures which has been there for 50 years. Now we are building algorithms which will better your estimates on position, which will better your estimates on security, on integrity, and which will provide you a gain. So let's say if my receiver is under the tunnel, Indian Army don't work over the field all the time, right? They will be working under bunkers, they'll be working under tunnels and all those different areas. So the gain is such that you will be able to receive the signals or your position estimates even in a compromised situation where all the signals are restricted or jammed. So two parts. Restricted is the signals is not able to penetrate the infrastructure. Second is jammed. So both of these problem will be solved by our own signal structure.
Yeah, it's interesting that you mentioned that there are 7 billion receivers. And just to add another point, I think I read somewhere from the time GPS was commercially made available, I mean, I think 60s, 70s, the value it has generated globally is in trillions of dollars.
Exactly.
So I think that sort of gives a sense of potential opportunity for companies like VyomIC in the coming decades as your solutions become adopted more. So in about 18 months, you're going to have your first technology demonstrator satellite which you're going to launch, and I'm thinking you'll use one of the commercial launches to put it in space. After that, can you talk about what are the plans in terms of, and I'm thinking you would probably have a constellation of satellites.
Right.
Initially, what's the plan for how many satellites? And typically, when you say low Earth orbit, that's the range. So, what is sort of the orbit where you are planning to put your satellites?
Yeah, right now we are optimizing all these parameters. So we have the plan ready. We are studying the existing constellation as well. So somewhere around in the range of 1,000 kilometers is what the orbit will be. So as I mentioned, LEO is less than 2,000 kilometers. Our satellites will be in thousand of kilometers range, and it will be a constellation of around 250 satellites. As I mentioned again, so we have to optimize a lot of parameters which is involved in this, keeping in mind the user perspective as well as the cost perspective. So the trade-off is still going on. We will come up with the final numbers in a couple of months.
So, once the technology demonstrator is like fully validated that everything's working fine, what's a rough timetable to have like the first set of satellites in space for you?
So we are moving very aggressively on this, and I was recently. So I'll give you a slightly long answer on this one. I'll not give you the straight away the timelines. So I was reading, not reading. I was listening to one of the podcasts by Elon Musk, and he mentioned that I put deadlines which is of 50% probability. So I know that this deadline has a 50% probability. I'll not be relaxed on my timelines. Let's say if I tell you that 3 years I'll be launching my first satellite, that would be very easy for me. I will manage the resources accordingly that I will launch the satellite in 3 years. But let's say what is the probability of launching the same satellite in 18 months? That is 50%. Now I will work towards this 50% probability timeline. So right now, for us to launch this satellite in space is 18 months. And we are working towards it. And as you mentioned about the possibly the proof of concept. So the first satellite will not be enough to provide the entire proof of concept of LEO PNT, though it will 90% of the job will be done. But for the entire constellation, at least we should have 4 satellites in space. The timeline of which, again, with 50% probability, is 3 years for us. So these are the timelines which we are looking at. Once this first satellite is proven, we will also think of having an entire production line for the entire constellation of 250 satellites, because the life of these satellites is 5 years, and every 5 years you have to replenish these satellites in space. So while we are working towards first satellite, we have already thought of the launch of 4 satellites. When we launch our first satellite, we will be also planning for the entire production unit. So this is how the timelines will look like for us.
Okay. Would it be fair to say that what you all will eventually offer will be something like next generation of PNT services? And if you think that's correct, can you give us a sense of who might be your natural customers?
Yeah, so actually that's correct. That's how we phrase it also. The new generation, the next age of navigation. So there, if I divide it into two parts, like a positioning navigation market and then a timing market, there are in positioning. I think we have 6, 7 major customer segments, which we are trying to cater to. First is definitely Indian defense. Then we have civilian drone operations, autonomous vehicles, precision agriculture, construction, and maritime. So these are the customers. I think almost all of the customer segments were trying to have conversations with the companies, the receivers who cater to these industries as such. Specifically, defense, we have had a lot of conversation, tried to understand their requirements, what kind of timelines they are looking at, what kind of precision would it be requiring. So that's on the positioning side market. The second is the timing. So time synchronization, we are looking at majorly 4 or 5 potential segments, I would say. The first one being telecom, which is I think one of the major players for timing because of the introduction of 5G and now moving towards 6G. More and more tight time synchronization would be required. Uh, Telecom, power grid, data centers, financial services. These are the 4 major segments which we are looking at in the timing sector as such. The mass market or the human, like the phones, laptops, watches, etc., are going to be our customers in near future, but not right away. So that's what our target market or our customer segment looks like.
Okay. As of now, can you give us a quick update on your investors' current funding, talks for next rounds and so on? Whatever you can share is fine.
Right. So right now we raised in September around $1.6 million, with Special Invest being the lead investor and Byte Capital and DVC participating in the round. This was the pre-seed round which we raised, through which we plan to do the demonstration as Lokesh and Anurag mentioned. And the next fundraise we would probably start after August, when we would be able to showcase our demonstration missions, etc. And yeah, that's when we would actually like to do that.
Okay. So now, over the next 18 months is the first tech demonstrator, and over the next 3 years is the first 4 tech demonstrators,
Right.
and then the satellite constellation, you'll start putting them in space. Is that sort of roughly the
Yeah. So
Exactly.
adding on to that, apart from being these 4 being the tech demonstrator, they would also start some pilots on the timing synchronization services, because timing, precise timing and secure timing is very important for uh, power grids, data centers, telecom, and defense as well. So that is something which we would like to start as well.
Okay. In this, I wanted you all to walk us through a couple of specifics that I came across, which I found interesting. First is the satellites talking amongst themselves,
Yeah.
and
Right.
then you also have developed tech, obviously,
So
for it to communicate with the ground. So
Yes.
walk us through the sort of what you would look at as the key innovations that you have developed there.
right. So the phrase that you mentioned basically means that is there is a inter-satellite link that is present between all the satellites. So all the satellites are connected to each other via this link. This is we have made this because we have to reduce the dependency on the ground segment. So we are not sure like the satellite that we want to talk to will be above the ground segment at a given point of time. So if let's say if you want to reach certain satellite and that is not on the ground, then you can use this link to communicate with that satellite. So that is one thing, that is communication. Second thing is, as Lokesh mentioned, precise orbit determination. Like the satellite needs to know what is the position of its own in the entire global coordinate system. And this inter-satellite link eventually gives one more additional measurement that goes into the computing of the its own position, and which makes its position at a centimeter level. Third thing is the synchronization of all the satellites with respect to each other. So if you look at the global time scale, the entire globe runs on one time scale, and all the navigation system needs to trace back to this common time scale, and with certain accuracy that depends on constellation to constellation. And so when we develop the Leo PNT system, that also needs to be traced back to the common time, that is UTC. And when you have this inter-satellite link, it is possible to sync your all the satellite timings within nanoseconds with respect to this UTC. So these are the 3 major advantages that inter-satellite link brings. And moreover that it drastically reduces the cost of infrastructure that is present like in the today's GNSS infrastructure. So this is inter-satellite link is one of the innovation that we are working on. Next is the atomic clocks. So if you look at the heritage satellites of any global constellation, those have this power consumption or the weight, the size of these atomic clocks are very very huge. And when we are saying LEO PNT, the satellite's weight and cost, weight and size that we are looking at is like at least 10 times or 20 times smaller than what they have used. So like naturally we can't use the atomic clocks that they have used in their system. So we have to make our innovation in such a way that we used the quartz component that are present today in the commercial market, make it suitable for the space application, make it precise such that the timing requirement that we are estimating for the LEO PNT that is served by these atomic clocks, and then make it space gray and then use it in the LEO PNT. So this is like this entire chain is one of the innovation that we are looking at right now.
And you all mentioned that there'll be fairly strong signal even inside buildings, in tunnels. I think the context of the armed forces, you mentioned that. So, does that fall into this area of what you all would call beyond visual line of sight?
No, this will. So we don't use this terminology in satellite navigation. This is more or less in the drone sector. So while previously we come from the drone background, so beyond line of sight is you will able to operate the drone from your normal line of sight, right? So for communication, line of sight is very important if you're not using any relay network. So and drones, it becomes even more important because your drone directly looks to your transmitter and receiver on the drone side. So beyond visual line of sight is for drone ecosystem, but in space you don't usually use this terminology.
Okay. Unless it's like really technical. So, this made me curious about how your signals would then actually work inside big buildings and tunnels as well. Can you give us a simple understanding of what happens?
Right. So, okay, this is, yeah, as you mentioned, this is slightly technical side. So, first is a very rudimentary answer for this is the signal strength. So, let's say if you have more signal strength, you will be able to get the signals inside your building. Just like your cellular towers will able to reach to your mobile inside your home, inside your buildings, right? Because they uh, uh, transmit more powerful signals. If you were able to do the same from the satellites, that would be great. Let's say what Starlink is trying to do, direct to cell. So they are trying to transmit more power from the space so that you will be able to receive your communication signals inside your building. But that would be very hard for a satellite communication constellation to do it, because in satellite communication you have two parameters. First is bandwidth, second is a strong signal power. Both of these will come at a cost. So these two have a direct relation among themselves. So they need to provide bandwidth as well as the signal power at the same time, which is very difficult to do it. That is why, like Elon Musk also mentioned in one of his podcasts, that satellite communication is not very viable in a urban environment, crowded urban environment. For us, the bandwidth part is relaxed. So we are not going to provide you some Mbps or Gbps of data. For us, it's 50 bits per second. So 50 bits per second is the navigation data rate, which we have to then transmit to the user. Now we have the luxury to give you signal strength because we are not providing you the bandwidth. So we can work on a larger area. Whereas if you see the satellite communication, they work on a focused beam, because to provide that level of bandwidth as well as signal power, you have to be very focused. We work on a very wide area. So let's say the beam width for our antenna would be somewhere around 100 degrees. So we can cater a very large, and it's not a two-way communication again. It's a single-way communication from satellite navigation. We just have to transmit the signal, and your receiver would then capture these signals and then estimate the location. Right. So it becomes slightly easier for the satellite navigation satellites to provide this. So yeah, coming back to your question, first is the power is increased, the bandwidth is less. Now coming to the signal architecture itself. Now there are techniques to provide you the coding gain. Now I'll explain you with an example. Let's say right now if you are using GPS, your signal strength in your receiver is minus 130 dBm, but your noise floor is minus 100 dBm. That means is your signal itself is suppressed under the noise floor, right? Now you need to take the navigation data which is suppressed under the noise floor. So for this, we have special techniques to use in the signal architecture, which is called CDMA technique. So it's a multi-axis technology. So we use spreading codes to spread the navigation data over a larger bandwidth. whereas your noise will be the same. Your noise will remain same, whereas my navigation signal is spread over a larger bandwidth. This is another technique where we are innovating. Depends like how good you make your spreading codes, the better is the coding gain. Again, it's not just the spreading codes, it's a bunch of different things. Let's say the modulation which you use in your signal architecture, the channel codings which will you using in your for error correcting codes in your signal architecture. All these things combined will give you the luxury of uh, getting the navigation output even when the signal is very very weak, and that's what we are innovating upon.
Okay. Can you walk us through, on the flip side, what are some of the challenges that still remain, in the way of a company like Vyomic? I mean, both specific to the space sector, in terms of your supply chain, maybe there are things that you still need to import, things like that. I mean, and any other things, like maybe there are some aspects of your technology where advanced manufacturing facilities may be required that may not necessarily be available in India. I'm just thinking aloud. In that sense, are there what might be some important challenges for you in terms of your overall operations and supply chain, funding, all of this? The second aspect was, of course, maybe, and the funding probably is more related to the broader deep tech. That is, the second part is more as a deep tech company, as any deep tech company, trying to develop your products out of India. So that's what I was trying to understand.
Right. Yeah. Then I think there are a couple of, not couple of, there are many challenges. So yeah, coming back to your question of supply chain first and any such advanced manufacturing facility kind of bottlenecks, definitely. So one of the key components, as Anurag mentioned, is the atomic clock. So we are working on quartz-based atomic clocks. So these components, we don't have any company in India who can supply these components to us. So we have to deal with foreign companies. In this case, we are dealing with US, we are dealing with New Zealand, we are dealing with uh, Europe as well. So we need to make our supply chain much more redundant. Uh, but again, it's a dependency on the foreign players. If tomorrow they tell me like we are not supplying you these components, then there is some issues. But I think there are a couple of companies in India already working on this particular sector, and we are in touch with them to uh, collaborate on development of this part as well. But yeah, this is definitely, supply chain is a big problem as of now. Again, let's say if I want to develop a satellite today, Indian companies, as we have very new in this space, correct? So we don't have a heritage as such. Let's say now I'm building a payload and I want a satellite bus to launch my satellite. Now, which Indian company will I go to? As of now, there are a couple of companies, to name a few. Let's say Dhruva is there, Pixel, Galaxy, Azista. All these companies have built their satellites and they are launching. But right now, the heritage does not exist for me to take a risk on the satellite bus. Then I have to move again abroad to look for these facilities. Now, one more problem is, let's say I'm looking at a constellation of 250 satellites. Now, this 250 satellites, uh, as of now, India have not launched 250 satellites till date. So we need to look at the production capability right now, which does not exist in India. Uh, so these are the challenges which are there. We don't even build our resistors and capacitors in India, right? I'm not criticizing, but yeah, I want to criticize as well. We don't build any such these components. Not even the resistor, right? For resistors, we have to go to China or US. So that's a big problem working in the deep tech startup. It's not a software which we can have the cloud storage and then build a software over it. Uh, Coming from the funding part, I think now uh, it would have been a challenge for people who have started space in India. Let's say Dhruva and then Agnikul, all these people who started back in 2016 and 2012 for Dhruva Space, they might have faced a lot of problems because people don't believe any private industry can build something for space in India. But now investors have a lot more trust because you can see that right now, as we speaking, there are 400 plus startups in India working in space background, and most of them are well funded. So investors have shown faith in Indian startup ecosystem. Also, they have been very patient with their capital. So they understand the revenue in this deep tech space startup will not come in 3 to 4 years. It will come after certain amount of period. So yeah, the patient capital which we always talk about is there now in India. We still need some more funds, as you can estimate, right? We If we want to launch 250 satellites, the amount of capital which we will require is enormous. So definitely more in capital influx is required as far as deep tech is concerned in India. But yeah, this is my take. People need to take PNT space more seriously. It is the backbone of all the critical infrastructure in India, be it defense, telecommunication, financial institutions, power grids, railways, anything. Uh, uh, right. So people need to talk more about PNT, and we are there to educate in this industry as well. We keep doing it from LinkedIn and through our other social media platforms. But yeah, we need to talk more and take this PNT domain more seriously than ever before.
Okay, fair enough. Since you mentioned there is much more investor awareness now, more patient capital available, is that translating into positive talks for your own next rounds of funding? I mean, would you say, sort of, tangibly or quantitatively, compared with, say, 3 years ago, today talks are going faster and more constructively?
Yes, I think today the talk is going more faster. The quantum which we talk is also have increased from the past. So the previously people used to say that 8 to 10 months is the usual time period for any investors to put on the money. Now I think they have reduced it because they understand the requirement for the startup side. The quantum has increased. They understand the deep tech startup need more money, more influx to even prove that prototype as well. So yeah, I think the entire ecosystem has evolved quite a bit from when we started back.
Right.
And there, yeah.
Yeah, so I think the patient capital, patience, which is generally required for deep tech startups, that it would be in an R&D phase for like a couple of years down the line, and then eventually 4 5 years down the line, it would see some revenues, some significant revenues. So that kind of capital is now coming. I think Special being one of the first in the industry to put in checks on
Mm.
these companies, and now there are more and more deep tech investors coming in. So I think the union minister also mentioned in the startup Mahakumbh, Mr. Piyush Goyal, about uh, like folks shifting the focus of investment and startup forming to deep tech instead of on other e-commerce or other areas as such. So I think that is being taken seriously also.
And I think the government support is equally important, and which we can see as of now. So the RDI fund, which is recently introduced, right? This gives flexibility to investors as well as the startups to think to that level, right? So at least most of the risk is being taken care by the government side as well from the capital perspective. So initiatives like TAF, the IDEX, and then RDI fund, this will make a little more easier for the startups to uh, take risk. Deep tech is something which not always be successful, right? So this has been a story in India, like we always go to make things frugal, economical. I think moving forward we are slightly moving away from this mindset. We don't have to be frugal at all the times, right? When it comes to a strategic innovative technologies, we have to be more innovative than frugal. uh, this is evolving as we speak. uh, yeah, this is the point which I've wanted to make, because see, Elon Musk, if you see the journey of SpaceX, right? The first three launches were failed, and then the fourth one got successful, and we all know like where the industry is as of now. We recently visited SpaceX facility. We see the Falcon 9, how they are building Falcon 9 and everything. So yeah, so that's a, like one line from my side is, rather than being frugal at all times, we have to be more innovative in deep tech as of now.
Also, like if you see at the talent pool that is available in India. So when I will tell you about what we are seeing. So the navigation that like earlier till now was done by ISRO, and there is very less people who know about navigation, like how navigation, and then the entire space industry as well. like space, how the things work in the space. Like there are very less, or there are graduation courses, post graduation courses, but there is no graduation course that teaches like from the basics, like what all works in space. And that is because the privatization has happened like in recent past. But the talent pool is something that is very very critical to make any industry in the space tech to survive and to achieve what it has to achieve. And this is where like significant efforts are needed in the today's scenario.
That's it for today. You can find links to VyomIC's website and its founders' bios in the show notes. If you're an aspiring founder in India, especially in space technologies, do look them up. I'll be back with another episode of Speciale Focus. Until then, it's goodbye from me, Hari Arakli. Thank you for joining us.